All right, so our last equation is going to concern this thing called a Q test. And whenever I see the Q, I think question. And whenever I think of question, hopefully this makes me think questionable point, because that's exactly what this equation is going to do. It's going to look at a set of data. One of your numbers maybe could be really high or really low, and you have a questionable point. Should I keep this number or should I discard it? And the Q test will let you know statistically whether you can keep it or discard it. So in the PowerPoint presentation, this is going to be the slide that we're working off of. And it says, imagine that you have this set of numbers: 12.56, 12.53, 12.47, 12.67, and 12.48. The question is, out of this set, 12.67 seems to be kind of high, at least higher than the others, right? 12.5-ish, 12.5-ish, 12.5-ish. Then we get a 12.7-ish, and then 12.5-ish. So out of the group, 12.67 seems to me that it's a little higher than the rest. So my precision and my accuracy maybe could be a little bit better if I get rid of that number. Well, if I'm working in a laboratory, I just can't decide to get rid of the number whenever I feel like getting rid of the number. That's not how it works. Quality systems have something in place called the Q test. And what they do is that they take a look at this data that you're reporting to them, and if you think that one of your points are questionable, then you can question that point. But you can't just kick it out whenever you feel like kicking it out because it makes your numbers better. You've got to statistically prove that you can legally kick it out of the data set. All right, so how do we do that? What does this equation look like? Well, this equation, again, hopefully is very simple. We have a Q calculated, and we take what we call the gap and we divide it by the range. So that is the equation that we will be using: gap divided by the range. All right, so let's take a look at the numbers that were given in the problem. So I'm going to shrink this down so that way I don't have to flip back and forth between everything. So we're going to get 12.56 and 12.53. So 12.56, 12.53, 12.47, 12.67, and then there was one more, I believe, and that one more was 12.48. All right, so I'm going to put a big question mark beside of 12.67. That's the number that we think maybe is a little off ball. That's the number that's questionable, that we would like to kick out because all of my other numbers seem to be close together. Typically, what most people do is that they question the highest or the lowest point in the data set. You don't want to really question the middle point because that middle point probably is closer to the other points in the data set. It's typically the extremities, the really low one or the really high one. That's the one that you always question whether or not you need to kick it out. You typically find the farthest away from the set. Okay? So the very first thing that I want to do is I want to order these, because that typically allows my job to go a little smoother. So I'm going to order them 12.47 and then 12.48, right? And I'm just going to cross these out as I write them down. 12.53 comes next. 12.56 is the next one. And then 12.67 is the next one. Okay, so we said that the questionable point is this one, Again, it's the extremity one. It's the one that's either the highest or the lowest. And in order to solve this, we have to find the gap and the range. All right, so what is the gap? Well, the gap is referring to basically the point that's questionable to the next one in line. That is the gap. Basically the difference. How far outside is this data point? So I'll take those two numbers and I subtract them. All right, so if I want to do that already before we go and talk about the range, I can. So I'm going to take 12.67 and I'm going to subtract 12.56 and I get 0.11. So the gap is 0.11. All right, the next piece to the puzzle is what we call the range. Okay, well, that's the range of numbers. You know, how big is the span of the data set that you're providing? So that's the minimum all the way to the maximum. And that includes the point that you're questioning that you want to kick out. And that is what we call the range. It's the window, basically. So the window is 12.67 minus 12.47. So if you need that on a calculator, 12.67 minus 12.47, and I hit enter, I get a 0.20, and that is what we call the range. So 0.20. All right, so to calculate my Q, I basically have all the points now that I need. And the only thing that I have to do is take 0.11 and divide it by 0.2. So 0.11 divided by 0.2, and I hit enter, and I see a 0.55 as an answer. And that is what we call the calculated Q. Now, what do we do with that number? Well, that number is going to tell me yes or no. But I have to compare it to something, just like we did with our student T's, right? We were always comparing my calculated T to a table T. The F test was the same way. I compared my calculated F to the table F. Well, I've got to do the same thing with the Q data. So in this PDF document, after the F test, you're going to see the Q test. And that basically is doing the same thing here that we are. It gives you an example. And then over here to the right, you're going to see a table. And that table is going to be the Q table value that we're going to compare to. So this table is based on a 90% confidence, which is what the Q is going to be based on every single time for us. And then over here to the right is the number of observations. Notice it's not the number of degrees of freedom. It's the actual number of measurements that you have. So if I go back and I count the number of data points, 1, 2, 3, 4, and 5, I'm going to go to this table and I'm going to go down to number 5, and I'm going to come over and I see a 0.64. So my Q calc and my Q table. My Q table's 0.64. Let me get rid of that mess. Look at that. So 0.64. Well, in this example, my calculated Q is less than my Q table, right? My calculated was 0.55 and my Q table was 0.64. So because of that, my Q calc is less than. That means I keep that data point. If my calculated Q was greater than the table, I would discard that data point. So by looking at these 5 numbers, I question 12.67. I take a look at this and say, you know, 12.67 is a little higher than the rest of the numbers, so I'm just going to kick it out. That's wrong. You can't do that. And the reason is because statistically, that falls within the set at the 90% confidence limit. So that is how we do the Q test, and that is the purpose of the Q test. It is for a questionable point. This allows you to kick out one point only. You can't repeatedly do this to keep kicking numbers out to make your data set statistically better just because you think it works that way. It doesn't. You can only do this once. And in this example, 12.67 we had to keep. Even though to us it seemed a little higher, even though to us it's off of the set, even though to us we feel like we should kick it out, statistically, using the Q test, we cannot. So we would have to keep that in your data set. We would have to report that as an actual measurement that affects your precision and that affects your accuracy. So again, it's very important to take a look at those two concepts throughout the entire time. All right, so that's the Q calc and the Q table. All right, so with that said, we are kind of finished with all of the random equations that we have or that we could see in a laboratory environment. And, you know, if you look at the very first page of this PowerPoint, this kind of proves why we have to go through all of this mess, because it says here we got a pregnancy test, and it says the test results are back. Johnny is pregnant. What? How on earth could that be? How can Johnny, if he's a male, take a pregnancy test and have it come back positive? Well, these kinds of things happen all the time, right? These are what we call false positives. The test came back as positive, but we know that there's just no way at all that it could be positive. Johnny is a boy. So these things happen. Companies have to go through this on a daily basis, and they fix these types of problems by using rules of statistics. These are fixed by things like the student T, like the comparison of the methods, like the F test, like the Q test. We know that certain things like this can happen, and hopefully the world of statistics will fix those types of things for us, because we guarantee that Johnny's probably not the only one to get a false positive. We probably have a pure or a poor female out there that has taken a pregnancy test as well that has turned out positive, and she's really not pregnant. So these things happen on a daily basis, and we expect it, and we know that it will go on, and statistics allows for us to fix for some of those problems. What I think is funny is up here at the top, this is a Craigslist ad, and it says, positive pregnancy test, $20. I am pregnant, and I will sell you my positive pregnancy test, $20 each. I don't care what. And the ad went on to say, I don't care what you're going to do with the pregnancy test. It's none of my business. I just want you to show up, give me $20, I'll pee on a stick and I'll give it to you, and I'll make some money. Some people. But, you know, this person probably made a killing off a positive pregnancy test. I don't know. Maybe I'm in the wrong business. Maybe you are too. Maybe we all should be selling pregnancy tests like this. Who knows? We could probably go on vacation with it. All right, so that's all of the statistics equations. Now, there's going to be some other things that you're going to see in the modules throughout this period. Some of these things are going to be how to handle what we call error, and we'll talk about that a little bit later. Some of these are going to be control charts and really what those mean and how to interpret those. But as far as statistics go, this is our confidence limits. These are our averages, our standard deviations, our t-test, q-test, and f-test. So I think that's enough to keep you busy for a while. And then upcoming and other modules will gradually release a little bit more here and there for you to fool with. But that's where this lecture module part is going to stop. So good luck on the test and good luck on the assignments. It's all going to be math-based for this part, but hopefully you'll be okay. You'll have your calculator, you'll have the tables, you'll have the equations in front of you. Hopefully you'll be ready to go. So stay tuned. This module is basically over, and in the upcoming modules, you might see a little bit more math. So you're not out of the hot water yet.